about plant diversity and how plant diversity is good for wildlife, it's good for soil health, and it's good for more forage for livestock. Wildflower blooms provide nectar and pollen for our pollinators. Many pollinators only use a specific plant or a certain genus of plants. Diversity can create a chain of insects for birds to feed their young. Insects are the bottom of the food chain for wildlife. Functional diversity groups: native warm season grasses, native cool season grasses, native wildflowers, and native legumes. NRCS has two principles of soil health: plant diversity and have a green growing plant in the soil as long as possible. So here we have a native warm season grass and a native cool season grass growing side by side throughout all the seasons. You can see here this southeast wall rye is seeded out. The seed heads are brown and dried down, whereas this Indian grass here is in the boot. So this one is actively growing and has been actively growing all summer, whereas this cool season grass was actively growing in the springtime. Let's look closer at big bluestem, a warm season grass. Here we are in late August. This big blue has been grazed previously, and you can see that the regrowth has more leaf and less stem in it. This southeast wild rye is a native cool season grass, and you can see its brown seed head it's finished blooming, and the seed is fully developed. And within the next grazing, this plant will be taken down to the ground, and then later on in September, as the temperatures cool, it will begin to regrow. And actually, grazing stimulates these plants to regrow. If they're not grazed, many times they do not regrow as our fall rains start. Grazing also cycles nutrients in the manure and urine. Getting plant residue to the ground encourages the microbes to begin the breakdown of this plant residue, into nutrients for the next growing plant. Warm season grasses are also more efficient with water than what cool season grasses are. Thus, they produce more biomass with less water. That is certainly adapted to Missouri's climate, where we have traditionally wet springs and hot, dry summers. Don't forget the wildflowers. The horizontal leaf orientation of these sunflowers fills and overlaps the voids in the solar collector. The vertical nature of grasses lets sunlight penetrate to the ground. Many wildflower leaves, such as this oxeye sunflower plant, are low and close to the ground in the early spring. As the warm season grasses grow and the stems bolt, the wildflower stems elongate as well, bringing the leaves up overhead where they can continue to receive the sun's energy and photosynthesize. We're looking at a big bluestem and an Indian grass growing here side by side. You can see where in August the big bluestem and Indian have seed-headed out, and as we look down into the soil pit, you can see that we have roots extending down to 4 feet deep, but we have a mass of roots, there in the middle. This southeast wild rye is not really competing, with the Indian grass or the big blue. Its roots are spread out there on top, just made to soak up small rains that might come along, and to use those shallow rains to get its nutrients. Again, and water. The southeast wild rye is a cool season grass, so traditionally we get more rain in the spring, and that plant then can soak it up. I've seen big bluestem and Indian grass in a dry year as compared to fescue, if we have a dry April, May, seems like the fescue is really slowed down in its growth, whereas these warm season grasses have the ability to store moisture deep in the soil, and they are more efficient. Their photosynthetic pathway is more efficient with water, so therefore they're able to go ahead and seemingly grow at a normal rate, in a dry spring. So we can see that the function of these different root systems of the southeast wall rye, being the shallower rooted system, creates more root biomass here at the top. And as this root biomass, goes through, lives and then dies, it adds more organic layers up here at the top that can help increase the water infiltration, as we come down into soil that is deeper, and that we have more of a massive amount of roots here within the first 18 inches, and then they start to peter out. We're here at this compass plant, and we're going to dig a little bit deeper down into the soil pit and look at roots today. So you can see the function of this taproot is different. The deep root can gather nutrients down deep and can also bring up water. Plants' roots will continue bringing up water at night, even though the plant cannot photosynthesize and use it. It brings that water up so that it is available for plant growth during the day. And this leakiness of that root system then allows some plants very close to that root to get water as well. The nutrients that are gathered deep, then if this plant is grazed, those nutrients then are moved around in the field and become available to another growing plant. So here we have a prairie cordgrass root. We're going to take a closer look at it. So you can see this here kind of wiry plant material up here high. And also you see the more green plant material right down here. You can see these underground rhizomes, these underground stems, and then the finer root hairs have the ability to hold on to soil, very tightly. And even this underground root system, it's kind of woven together like a rug, making it possible for even livestock to stand on this root system and have the strength, to hold up under that. Maximilian sunflower root. Let's look a little closer at it. Soil level is about right here where my fingers are, and everything below that then goes underground. Let me show you how tough these roots are. You can see they're pretty woody and difficult to break. Microbes decompose woody roots in the soil slowly. You can see the sugars and starches were eaten out of this root already, leaving a sponge-like structure remaining to soak up water. And then this water is channeled into the soil where it can so that it can enter the soil faster, thus increasing infiltration rates. At some point in the decomposition process, these woody roots are broken down even more. And these compounds then come in contact with clay and nitrogen. That's when humus can be formed. And humus is the long-lasting part of the organic matter fraction. Here we have 2 clods of dirt from beside a Maximilian sunflower plant. And then over here, we have 2 clods of dirt that come from a fescue field. You can see the one from the fescue field is more tight and just doesn't have the structure to it, possibly because those fine roots, just rot and collapse more easily Whereas the sunflower roots, as big around as your finger, keep these pathways open and develop that structure better and longer than what the fescue does. We've looked at a lot of diversity above ground and the diversity of roots below ground. Because each plant has its own special function in the grassland, it is important to have many different species. Begin by including plants from the 4 functional diversity groups: native warm season grasses, native cool season grasses, native wildflowers, and native legumes. Include many species from each group because they each have different above and below ground characteristics that benefit soil health, provide for better wildlife habitats, and, if grazing, produce more.